Hello and welcome to helpyourmath.com. In this video, we are going to look at an introduction to exponents. So first of all, what is an exponent? Well, we might know it as like a little superscript thing. It's that small number that's also kind of bossy. And yeah, that's pretty much what we're going to look at. So we're going to have like a normal size base, that's called the base, and then we have this exponent up here, which I'll call x. So I mentioned b is the base of this thing, and x is the exponent. And the entire thing is called a power. So this whole thing put together is called a power. And the way that we read this is we would read this as b to the x or b to the power of x. B to the x or b to the power of x. And what it means is whatever that exponent is, it wants that base to be a factor that many times. So if it was, let's say, b to the fourth, this would mean b times b times b times b. So there would be 4 b's. This is the second operation in the order of operations. And it's because it is just like repeated multiplication. That's why we have it, because writing out 4 b's is kind of annoying. Or like if it was b to the 9th and you had to write out 9 factors of b, that would be a lot to count. It's a lot more condensed if we could just say b to the 9th. The two that we need to be careful with, because they do have other ways of saying them, is if we saw something like this with an exponent of 2. So we could say b to the second power or b to the power of 2. But we could also say that it's b squared. So this is the same thing as saying b squared. And the reason for that, the reason we bring geometry into this, is because if we had a square with a side length of b, the area of that square would be b times b, or b to the second power. So just because it's used so frequently and because it does serve a lot of purposes in geometry, we can also say b to the second power is b squared. The other one that gets a special name is b cubed. So if we have b to the third power, we might say that this is b cubed, and it's a similar idea. If we had a cube with an edge length of b, the volume of that cube would be b times b times b, or b to the third power. So just because they're used so frequently, and because they do relate beautifully with geometry, we have b squared and b cubed. In our first example, we're going to rewrite using exponents. So we're going to be given the multiplication, the repeated multiplication, and we're going to rewrite using exponents. In letter A, we have, let's see, x times x times x times x times x. So the base, the thing that's being repeated, is x. And how many times is it being repeated? 4 times. So we would say that that's x to the 4th. In letter B, what's the base? What thing is getting multiplied over and over again? The base is 4. And how many 4s are there? Let's see, there's 1, 2, 3, 4, 5, 6, 7, 8. So this would be 4 to the 8th. Much better. Okay, and these last two examples, so in letter C, what is the base? What's getting repeated over and over again? In letter C, it's just h. The base of that thing that's being repeated is just h. It's a little bit weird, like what's the deal with that first thing? That first factor looks like 4h, but remember, when we have a number and a variable, we can squish them together, but this still means 4 times h. So the 4 is its own separate factor. It's not being repeated at all, right? I only see one factor of 4. So when we go to write this, we're just going to say, well, we have 4 times, and maybe I do the dot just to really emphasize. And now how many h's do I have? I have 1, 2, 3, 4, 5, 6, 7. So here I'm going to say 4 times h to the 7th. And order of operations says we would calculate that exponent first, and then whatever we get for h to the 7th, we would then multiply by 4. In letter D, okay, now it's a little bit different, because in letter D, what's repeating? The 4h is repeating. So in this case, our base is going to be 4h, but because there are 2 factors that are part of this base, I might need to put it in parentheses to say this is the thing that's being repeated. And then how many 4h's are there? There's 1, 2, 3, 4, 5, 6, 7. So one way we could write this is 4h in parentheses, because now this is indicating that there are 7 factors of 4 and 7 factors of h. The other thing we could do is we could split them up, right? Because again, we could take each of these things and put dots in between the 4's and the h's. So 4 times h times 4 times h times 4, so on and so forth. So the other thing we could say, if we wanted to, is that there are 7 factors of 4 being multiplied by 7 factors of h. I think either of those would be satisfactory for this question. And our last 2 examples, so this is something that is a common mistake as we go through math, so I want to talk about it now. In letter E, what is the base? What is the thing that's being repeated? And we might say that it's negative 1w, and we will say that because that's what I see over and over again. So I'm going to keep it inside parentheses just because there are 2 things here. How many times does it repeat? I see 4 factors of negative 1w. Now the thing is, we don't really need the 1. The 1 is what we call the multiplicative identity, meaning there's always, anytime we see a factor, it's always being multiplied by 1. I call 1 the invisible factor because it's always there. So we don't actually need to write the negative 1. We could just say that it's negative and then w to the 4th. So either of those would be fine. However, in letter F, what's the thing that's being repeated? In letter F, it's just the w, right? There's just that 1 factor of negative 1. So this one, there's a w being repeated 4 times, and then it's being multiplied by negative 1. And again, we don't need to write the 1, so we could say negative w to the 4th. Now we need to be careful here because if we plug in a number for w, like let's say we plug in 3, in letter E, if we plug in 3, our final result will be positive because it's going to be negative 3, 1, negative 3, 2, negative 3, 3, negative 3, 4. That's going to multiply to positive 81. Whereas in letter F, w of 3 to the 4th, well, 3 to the 4th is 81, and then we're putting the negative in front of that 81, so the answer in letter F would be negative 81. So very tricky there. If you want the thing that's negative to be raised to the power, you need to put it inside parentheses like we see in letter E. The negative by itself, this thing here, when we're plugging in or if we did have a value for w, the negative is treated as multiplication because it is like negative 1 times this thing, and we would do multiplications after we do the exponents. Okay, so we're going to identify the factors and the bases of each term. So the factors are the things that are being multiplied. So in a term, factors are the things being multiplied. And that's the only thing that's happening to them. Things only being multiplied. And the bases are the things that are separated by multiplication, but they might have exponents. So in number 1, in question 1 here, well, the 6 and the m, those are the factors and they're also the bases because we don't see exponents. And just like we had our multiplicative identity of 1, the exponent identity is also 1. If you don't see an exponent, there's an invisible exponent of 1. So in this question 1, the factors of this term are 6 and m, and the bases are 6 and m. In question 2, so question 2, I actually just had a really good discussion with my colleagues about this, about what exactly the factors and the bases are. So I'm going to show 2 different ways, and hopefully one of the ways makes sense to you and you like it, and we're going to stick with it. So I would argue that question 2 has 5 factors. Because remember, these are the things that are only being multiplied, so we would expand the a and write it as the a squared and write it as a times a. I would also argue that the negative doesn't necessarily belong to any of those other numbers. The negative is its own factor, and it's a factor of negative 1. So when I'm writing out the factors, I'm going to say negative 1 is its own factor, 2 is its own factor, then there are 2 a's and 1 factor of b. You could also just say there are 2 factors of a. Meanwhile, the bases, so these are just the things that have exponents. Again, I would say negative 1, 2, a, and b. Those would be the bases. Now, I think this is getting very technical, and probably if you said the factors were -2, A, and B, I think that would also be sufficient. But it's just, it very much depends on how you want to interpret that negative sign. And most of the time it probably won't matter, so that's the good news. But kind of just remember that negative doesn't necessarily belong to the 2. If I wanted to belong to the 2, I would put it inside parentheses. And then we could also probably say the bases are -2, A and B. So I think either of these are fine. I think separating the negative out is probably a tiny bit more correct, but either way is probably fine. Okay, what about question 3? What are the factors and what are the bases in question 3? What I would suggest doing, because right now we see question 3 has a fraction, let's rewrite it so that the fraction only contains that denominator, and then we'll use that multiplicative identity to help us write it. So what we can do is we can take everything in the numerator and kind of shove it behind, and then we're going to have that just a leftover 1, because there's always that leftover factor of 1, and we're going to rewrite it as 1/7 times f squared times g times h to the 4th. That way we're just kind of separating that factor from the rest. And again, you could always put the f squared g h to the 4th over 1 and get back to where we started. And now we can see the factors here. We have a factor of 1/7, a factor of f, another factor of f, g, and then we have these 4 h's. And then we would say the bases, so just the things that are being raised to powers, we have a base of 1/7, a base of f, a base of g, and a base of h. I also had a question today about like the g being lumped together with the h, but g is its own separate factor. It's its own separate base. It has that invisible exponent of 1. So it is its own. It doesn't get lumped with the h. If I wanted it to, I would put it inside parentheses. So it would say parentheses around the gh, that thing raised to the 4th. And then in question 4, as it is right now, this one contains 3 factors and 3 bases. So these are going to be the same. So I'm just going to say factors equal bases. And the things separated only by multiplication are 5 times x minus 2. So it contains these 3 separate distinct factors. If we were to distribute, that would be a different story. But as it is right now, the 5 is its own factor slash base. The x is its own factor slash base. The x minus 2 is its own factor slash base. For our last example in this presentation, now we're going to go the other way. So first we saw that we were going to simplify. Now we're going to expand and simplify. So because I give you all numerical bases, you're going to tell me what the actual final answer is. 3 to the 5th means we want 5 factors of 3. So 1, 2, 3, 4, and 5. And now when we multiply, so we can only ever multiply 2 numbers together at a time. You can't do 3 times 3 times 3 at once. You have to do 3 times 3, and then you can multiply the third 3 by the product of the first 2. So however you want to do this, the 2 most common ways to multiply this, if you're doing it by hand, is to just go from left to right. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. So those 5 3's multiply to 243. Alternatively, you could do 3 times 3 is 9. Another 3 times 3 is 9. 9 times 9 is 81, and then you can get the 243 that way. Either way is totally fine. Now look carefully at questions 5 and 6, and let's be very careful about what the base is here. So in question 5, what's the base? Well, because there's no parentheses, that negative is treated like multiplication, right? That's like that factor of -1. So the negative just kind of chills out in front. We repeat the 2 4 times. So basically we do this first. This is the same as doing this and then just attaching the negative to it. Or this is thinking about this being -1 times 2 to the 4th. Here we have 2 times 2 is 4 and another 2 times 2 is 4. We have a negative times 4 times 4. This would be -16. Versus question 6, where now it's saying the base will be -2. So this is -2 times -2 times -2 times negative 2. Negative times negative is positive, so this is positive 4. Negative times negative is positive, so this is positive 4. And 4 times 4 is positive 16. This has been an introduction to exponents. Thank you for stopping by.